welcome everyone. Like he said, I'm going to talk about Wobserver. Just everyone had a slide, so I'm going to say the man behind the beard. Like he said, I work for Square Enix. Why is that relevant? We've been using Elixir in production for a while now, and actually we've run into a few things. And if you've seen the previous talk my colleague Tetsuya did, we have our own solutions for those problems. And one of them was Task Bunny, and now I'm going to talk about Wobserver. That's what I'm going to do. So, Wobserver, you might say, what? It's Web Observer. It's a web-based metrics monitoring, and actually pretty much the Erlang observer in web form. Then you might ask, why? And why is Observer is great, especially when we started out. It was great to be able to see inside the state of our processes, to see what was going on, to see inside the tables. It's great for understanding, but sadly enough, we could not always use it. And why couldn't we use it? Well, we have a setup with microservices, remote deployment behind firewalls, load balancers. Everything is in Docker containers. We have lazy DevOps, as the picture shows, who has arbitrary CI rules that say you get one port per Docker container, not more, just one. All the other teams do with one port, so you should do too. That is what we have to work with. So you get projects like this that try to solve that. There are, of course, alternatives. So, for example, you could just use SSH, connect to the machine you want to use Observer on, and tunnel through that SSH to get the same, well, usability. There are a few problems with that alternative, though. You need to have SSH access to the machine, which could be handled. But you also need to set up the Erlang VM in a specific way to accept the tunnel. And if you have multiple instances on multiple Docker containers behind, for example, a load balancer, it's kind of hard to iterate and go this node, that node, this node. So that is why we came up with Wobserver. So the web interface takes kind of care of the remote part. You can just use the web interface to see into the application, have the same functionality. It doesn't really solve the load balancer part. So how did we solve that? Take, for example, this situation. We have an application. We have 5 instances running behind the load balancer. That means every HTTP request we do ends up at one of these 5. So if we want to inspect, for example, number 5, we either have to keep refreshing and hope we hit the 5th instance, or try something else to force the request to go to that specific node. Wobserver solves that problem by making the instances discover each other, and if the HTTP request ends up at a node where it wasn't supposed to end up at, so for example, we want to inspect node 4, but it ends up at node 2, then behind the load balancer, it will proxy that request to the right instance to make sure you get the information you want. So what does Wobserver offer? I have here a list. It's pretty much just the same thing the normal observer offers, but then for security reasons, we kept it, plus we were lazy, we kept it pure read mode. So you can see the information, you cannot change or kill or do anything like that. I can go through it, but I'm going to give a demo in a moment, so this is just a quick overview. It does offer something more, and that is it gives all the information also through a JSON API. And why did we add that? It's easier for automation, so you can check the state of the system with something else, because pretty much everything can parse JSON and do HTTP requests. You can get a list of all nodes through the JSON. And the normal UI works through WebSockets. If for some reason the WebSockets don't work, which can be with a load balancer or a firewall that doesn't really like them, then it will fall back to using the JSON API. We also added a feature that adds metrics. Metrics as in how much memory is being used, and if you want to add them custom counters like requests coming in or requests per second, stuff like that. They're basically formatted for Prometheus. That's just an application to graph and monitor systems through metrics. You can write or set in the config any metric system you want. It is not hard-coded that way. So just to show you, how do you get started with Wobserver? So hopefully, I'm going to say the Wi-Fi works, because then I can just give a live demo. I'm going to open the terminal. I made a, just going to make a new project. Demo, that works. Make a new project, and the only thing I'm going to change, see if Xcode starts, is in the mix file. Make it bigger, it's a bit too big. I'm gonna add the dependency. Hopefully I won't make any typos. Should be good. And I'm gonna do mix depscat. That's already there. Nope. We have internet. That's amazing. So I'm just going to start it and keep talking, because it takes a while to compile. So the only thing you need to do to get it running is bring in the dependency, and that's it. If you only want your Wobserver instance to run in develop mode, if that is something you want, you just add that to the dependency, and you won't even notice or have Wobserver there while you're running in production. So it's done compiling. I'm going to try it out. Oh, I'll make it smaller. So like this, bigger. And what we have here is the interface. I scaled it down. It does resize. Oh, here it resizes it. Now it takes too much information. Like I said, the original started as a replacement for Wobserver, because we ran into the problem that we couldn't use it. So here we have the same setup we had. We have the load charts. It shouldn't really be doing anything right now, but the charting, I'm just going to show you, then you at least know what it does. You have the memory allocators. I made the interface, but I'm a backend developer, so not everything is very nice looking. I'm very open to people wanting to help out there, because it's just not my thing. We have the same application. We added some colors to know what supervisors and applications and stuff like that are. You can use the same thing as in the Observer, so you can click them and see the state and click through the processes. Same for the process lists, the ports list. I'm just showing you how it works. And the table viewer. I'm not sure if I can pick one that has, the Elixir config. Always has options. So this pretty much works in the same way as the normal Observer would work. Read-only mode, but then through the web version. Can also show you what metrics would look like. For people familiar with Prometheus, this is the format that it uses. If not, it's pretty much one line of help, one line defining the type, and then the metrics information, which in this case just shows I/O and memory usage. Just to give an example of the API, it gives the same information, but then JSON format. And like I said, if you want to view them, there's only one node, because I'm not connected to anything, but it gives us a list of all the nodes it's connected to. So let's kill this just to make sure that I don't keep it running. So that is everything you need to do to get it running. We try to keep it as drop-in as possible. You just drop it in, use it. When you don't need it anymore, take it out, and it's gone. No setup, nothing necessary. By default, it runs on port 4001, and that's just because most web applications seem to run on 4000 by default, so we're just one up. If you want to work on it on your own, you can clone the repo, do mix depscat, and you might think it works then, but it doesn't, because we did some strange stuff to get it to work with distillery. It uses an assets pipeline, kind of like Phoenix, but then we tried to keep it small, which might not have been the best idea. You need to do an npm install, and we added a mix file called mix-build just to build the assets. So if you want to try it out and clone the repo, you first need to do these two things to get it running. We use Gulp for the assets pipeline. Like I said, I'm a backend developer. I just picked that up because I knew how it worked. It's not really relevant. Now, the interesting part. We made it to be drop in, drop out, but we started getting requests to make it possible to integrate it with running web applications, things that were already running Phoenix or Cowboy or things like that. So we started out making it into a plug. It was by default pretty much already a plug, but we just made it all contained in one plug. So if you want to run it and you already have Cowboy running, just start a new project with Cowboy. You don't actually have to add Cowboy and plug because they're already in Wobserver, but if you want to remove it, it's good to have it in. You have your standard Cowboy router. I'm not sure, are there people who haven't used Phoenix or Cowboy? Just so I know if I have to explain something here. It seems most people did. Well, that's easy then. We have the standard plug router, and the only thing you need to add is hey /Wobserver or whatever you want to the Wobserver web router. That takes care of everything. If you want the WebSockets to work, however, you need to start Cowboy with a child spec, and we need to do that because we need to set the options for the WebSocket. So if anyone has not worked with Cowboy and WebSockets, you need to define which endpoints take the WebSocket connections, stuff like that. You need to set options, and the options kind of look like this. You need to define like, hey, for things ending with Wobserver/WebSocket, send it to this thing to handle it. If not, send it through to our default router. I have this code all in samples, so if anyone wants to review, you can just look at it on GitHub. You can see it. You can, again, run Wobserver, and it should be running on the same port as your Cowboy instance. And I said, everything works right. It does not. Problem is, because we build it so that anyone could just drop in, use it, it will always start its own Cowboy server to serve itself. So we need to disable that. And luckily, that is as easy as setting the config to use plug instead of standalone. That will prevent Wobserver from starting its own Cowboy instance, getting it running. I'm going to talk about it later, but you also need to set the remote URL prefix. The reason is we ran into the thing where we only got one port, and that made us do some creative things because we can only use one port. So all the nodes interconnect, not through the standard Erlang system, but through WebSockets. So if you don't let the other nodes know that you've changed your own URL, it's going to assume it's at /ws. So you need to set the prefix so they can find each other and interconnect because they use the WebSockets. Phoenix is even easier. You start a new Phoenix project. I can show you. Hopefully it is actually very easy. I'm going to copy the code though because I can't copy the code, okay? Then I'm just going to type it. Yeah, thank you. Thank you for remembering. New Phoenix project. Starting up. You know what? Give me a second. Just pretend we did it. That's faster. We don't have to. It's pretty much the same thing as it just now. We started a new project. Just the default Phoenix project, nothing special. Added the same configuration as I did for Cowboy, so telling Wobserver, run in plug mode, set your URL prefix, And there are only 2 files you need to change. Apart from that, like I said, it's even easier. Oh. Got the Phoenix endpoint. You need to add the Wobserver Phoenix socket to your endpoint. We built, or at least someone in the community was very nice and contributed this module, so it was very easy to integrate. You add it as a Phoenix socket on /Wobserver, and in the router, need to pick the right one, so many routers, you do the same thing and you forward it to the Wobserver router, and what you will get is something like this. Don't mind all the Postgres errors. That's just because we don't have a database running. We have the normal Phoenix page, but then with Wobserver running behind it. We can use applications, for example, to now look into the Phoenix processes if we wanted to. All works the same. Gonna go back. This is pretty much what I just showed you. Add it to the config, add it to the router, for the socket, add it to the endpoint. And it works. Yesterday, or at least we had the problem that we couldn't discover the other nodes because we have them running in separate Docker containers, no way to interconnect them, but through the WebSockets we set up. So we needed to find a different way to discover where all the other nodes were. And what we used for that is a solution where, like I showed at the start, we proxy the requests through whatever node receives them, and then that node will take care of relaying them to whatever it was meant for. Metrics, on the other end, because they are metrics, are not proxied. The one node getting the request will just aggregate them from all the other nodes, take them together, and make one big file of metrics saying like, hey, this node is using so much memory, and this node is using that much memory. But the question is, how do we find those other nodes? And I think one of the other talks already went into it. The easiest thing for us was to use DNS. All the nodes are under the same search. So we search for the, well, obviously not this, because this wouldn't work, but for the one we use internally. And I can show you the code. This is actually all we did. Because we're using Erlang, we need to convert the string to a character list. Then we do an INET lookup for a A1, and then every result we get, we map to a node. The question is now, what is a node? I'm quite ashamed to show you this. I wrote it quite a while back. A node is a struct defined by a name, a host, a port, and local with a question mark. I'm very sorry about that question mark. The name is just to make sure, or at least to identify for users the different nodes. The host is the IP address, or DNS if you prefer it, like a host name. And the port is the port where to find the other instances on. What we do in this example is just go through all the results we get from the DNS lookup and map them to the different nodes. You can also, if you like, add your custom discoveries. We could use this because it was set up in a cluster like this. If you have another way where your nodes are still separated and isolated, but there is some logic you can use to find them, then you can just set in the config that you want to use custom discovery and point at a function to do that discovery for you. As long as the function returns a list of those nodes, it's all working well. Then I got an interesting question yesterday from someone using Wobserver saying, hey, I have my nodes connected. They are behind a firewall, so I like to remotely view them through Wobserver. But it's not like they're disconnected among each other. They can just see each other like a normal connected nodes. How do I get Wobserver to show the other nodes? And yeah, you can't really. That is a mistake. the second question was, shouldn't they do that? And the answer is yes. Yes, we should have thought about that. It's actually funny because our setup, we've never worked with them actually being connected. So we just never thought of building in the functionality to use the Erlang stuff that is already there to get the nodes to relay the information. So I did write, and this is a nice example, a way for them to get it to work. Okay, so let's add it. It will show you how to do the custom node discovery. I wrote a method, and I just called it node info. Gave it a default false for local, and that local is very important. The local, I didn't explain it until now, defines whether the node for that one, this remote node is the one on that node itself. So every node in the system has a list of all the other ones, but that list includes itself. And to prevent it from ending up in a situation where you get a request that is for this node, but it sees itself in the list, so it proxies the request to itself, where it finds itself in the list, and it just ends up proxying it to itself. We use the local one to define, like, hey, this one, if you get a request for this one, that is you. Don't go proxying it, just handle it yourself, so you don't end up in a loop. As name, I'm just going to use the node string. That is it. The port is just a configured port. So how am I going to get that remote node information? I'm going to use process messages, and when someone requests the information about a remote node, they need to supply a caller pit, say like, hey, I want to know what your information is, and what the function does is use our node info with the default parameter, so saying false, this is not you, and send that back to the caller, so the caller knows that this node exists and where it is, which IP to use. The beauty of this is that these process messages in Erlang work across the nodes. So I can just answer a pit that is not on the same machine, but on a different machine that is connected. So this logic is very simple, but still works through the beauty of Erlang. So how do we get the information of one node then? I'm going to use remote node. And what that is the identifier of a node. So in Erlang, you have the different identifiers. Can be a name at, and then either the local host name or whatever. And what I'm going to do is use node spawn, which will spawn a process on that different Erlang node. And what I'm going to do is, on that remote Erlang node, use the remote node function. I'm sorry, I'm very bad at naming everything the same. So this function, we're going to call that, and we're going to pass this guy's process ID. That means that everyone will get a message from this guy saying, hey, can you send me your process information? Which they will get, and then send back to the process on that specific node. We all wrap that in a task, and that task will spawn this on the different one, and then wait for the reply back with the node information. Reason we do it like this is so we can do this. Like I said before, every list of nodes requires the node itself to also be in there. So the first one, we just generate node information with true, because that is the local one. And apart from that, we're going to use node list, which lists all connected Erlang nodes on different machines, or maybe on the same machine, but just running on different virtual machine. We're going to use check node, which was above here, which will start the async task of sending a message to that node saying, hey, tell me about yourself, and then send it back, and waiting for the response. And then using task await to wait for all the results of those queries. This needs some cleanup, because this is just a short example, because what if one fails, then it all errors out. In a non-failing scenario, this works. But it is an example to show you how you can still use the configurability, terrible word, to discover the other nodes in this system. Does this solve the problem? Kinda. It now works, but we still need to implement it in a way where it actually doesn't use remote connections over WebSockets or something else if it can already connect to the node using the normal process messages. That's just a waste. Now I'm going to talk about extending, about how to extend Wobserver if you want to add more status information, if you want more metrics, more status information on the default page. Metrics, easiest one to start with. If you want to generate more metrics, you can set them in the config. By default, we offer two types, counter and, I never know how to pronounce this word, gauge, something, gauge. We're going to do gauge. Gauge, difference is a counter can only go up, or should only go up. That is, metrics where you count something. It's standard for Prometheus to use these types, so we just started using them too. Gauge can go up and down, which, for example, could be memory usage, which should go up and down. Our I/O, as in how much I/O we've used, should only go up, shouldn't go down. It would be weird if it went down. How do you configure those things? I've got a configuration example here. You just define metrics. You say, hey, I have additional metrics, and my additional metric is called marbles, and this marbles method generates the actual data, so it sets like, we have 5 marbles, 6 marbles, whatever. It's a gauge, so we can lose marbles for some reason, and we call it marbles. You can also, if you have a system where beforehand you don't know which metrics you're going to have, so in this example, we know we're going to have marbles, but what if we have a system where a customer creates different stores, for example, we don't know which metrics we want for those stores, then you can use a metric generator, which generates the different marbles. To show you an example, just going to open here the extending one. This one I can run. Being scaled very badly. So for the marbles, for example, you can return a list of data. And what happens is, I say I have 5 marbles where the color is blue and the shape is square. Shouldn't have added that. I have 8 marbles that are red and a cube, and 1 marble that is green and shaped like a pear. So how does that end up in Wobserver? Nice. It automatically reconnects, but we switched port, so it doesn't. Oh, I was going to say live demos, as I ever see. Showing up metrics. As you can see, you get the metrics in there saying shape, color, and how many. You might also notice that a node is defined. That is because metrics get aggregated for every node in the system, so that Prometheus or whatever system you use knows like, hey, in total we might have this many marbles, but 8 of them are on that node, 6 of them are on that node, and if you had more nodes, they would show up here. You might also see that I added some flight nodes. I can show you those. I set those in the configuration as a generator, and you can see that it pretty much generates it in the same way. So here we already give marbles, but the generator returns the same structure, but then dynamically, with, again, something that sets altitude, ground speed. Then you might want to extend it not with metrics, but additional pages. So you want another tab in Wobserver that shows data about your system. So we talked, for example, about Task Bunny, our other project that handles background jobs. You might want to add a page that shows you how many background jobs you have running, or how many of those have failed. That is a good way then to add a page There are two options for pages. You can set if it's API only. That is if you want to generate some data that's only used for automating. And refresh. If you have, for example, a page that shows static information, the WebSocket doesn't have to be used to keep asking like, hey, do you have new stuff? Do you have new stuff? You can just set it to 0. If you have something that draws a graph, it might be nice to get quick updates so it turns into a nice graph. So you can set the refresh rate lower, like 0.5, something like that. So how do you generate them? Well, you can either give a map, and that will show up as a key value table, or you can give a list of maps, and that will show up as a table where every map is a row in the table. To show you, here I've defined a stable, and in this table we have a test, and that is a row of maps with data, and we have a table that is just one map. And they will come out as a table with different rows for the one as a list, and this key value table for the one that's being used as just a map. As you can see again, I'm not a front-end developer. It's all a bit, If anyone wants to contribute, feel free because I'm open to changes there. These pages, you can generate the one I just showed you pretty much in the same way. You give a title, you give a command that is used over the WebSocket or in the API to get this data, and a method, a function that generates the data. Then there's one problem. What if, like TaskBunny, you write a library that a user can use, but that user might not have Wobserver, but you still want to give people who use Wobserver the information about your library. Then you can dynamically add your pages or metrics using register, and the configuration is pretty much the same as in the config file, apart from that you do it manually and say wobserver.register. I added a line of code above that, so you can just at startup run this. It checks whether Wobserver is actually included in your project at compile time to make sure you don't really need to use it. Yeah? Sorry. Yeah. Does this work even for users without Wobserver? It does. It annoyingly generates warnings saying, hey, you're calling Wobserver doesn't exist. Very quickly, how can you solve that? You can either use apply instead of writing, like in the example, wobserver.register, so apply, wobserver, register. Use the callback like that. Or you can set the xref option in your project to exclude generating warnings if calls are made to a specific module that might not exist. That is, I feel, the easiest, but apply works without changing your mix file. If you want to take a look into the code is structured as such. In the system directory are all system statistic code. In util, you can find all the observer functionality. So that is like the node list, stuff like that. In util metrics, you can find all metric formatting if you are interested. Util node for all the node stuff. And the source directory and the gulp.js directory are used to build the web assets. A little bit of reflection at the end. We made quite some mistakes. We made the project quite hard by mixing a lot of concerns, the interconnecting nodes, the web interface, the metrics, the system monitoring. They're all interconnected, and that made it very hard to keep the project going because there are so many things that are kind of hooking into each other. I wouldn't do that again if I were to redo the project. We could keep them more separate, keep them, if possible, as even different projects. The WebSocket handling can be better, should be improved. There were some requests for security. I haven't shown it. It is possible to add some form of authorization on top of it. but because it was like an afterthought, the implementation is not great. Like I said before, nodes that are already connected, you need to use the code I just posted. Should have done that out of the box, just connecting to them. You didn't see that. And the asset setup is pretty impractical. We started this project because we had a need for it. We were still pretty inexperienced with Elixir. We had been using it for a bit, but we know so much more now. So if there's going to be a version 0.2, we would split the concerns, make the node interactivity better, and do the security from the start, and probably get someone or something to make a nice interface or diagrams. If anyone has any questions or wants to know more about what we do with Elixir at Square Enix, just drop by for a chat. We're always looking for new developers, especially Elixir developers who are interested. And if you want to see the code examples or download the slides to review it, they're all on GitHub.
Let's give them a round of applause. Up next is the break, and because of that, we can do a short Q&A, but if you would rather just go and get some snacks I think they're going to have out there, then that's perfectly fine. So let's start with some hands.
Hey, so nice presentation. I think Wobserver looks great. I actually have a question.
Yeah?
So Wobserver has some performance overhead when it's used in production.
Yeah?
Does Wobserver add any additional overhead on top of Wobserver?
No, we actually don't use any observer code, so it's all been...
Oh, you use the internal library, is that it?
No, we wrote everything from scratch, so we're not reusing stuff like that. We tried to keep it as lightweight as possible, so where... my pictures directory. So what it does is it takes some shortcuts it can take because it's just for monitoring and not generating pictures. I can do this. Because it takes some shortcuts because it doesn't need the ability to kill or to be detailed. It is a little bit more lightweight than the original observer, but like I said, that's because the shortcuts were possible in the monitoring.
All right, any other questions? See some hands, awesome.
Have you also considered adding tracing to Wobserver, so the ability to trace functions?
I have to check to do. It is not something we've not thought about. It is just like he mentioned with the performance overhead, we try to keep it by default as drop-in and lightweight as possible. So there are no traces available now. It is probably something, like I said, for the 0.2, I would like to keep it more modular and actually keep the web interface as something that reports the data it gets in a more generic way than the pages do now, because they're pretty limited, as in they can't do graphs, stuff like that. And then write the observer part as a separate module you can also include that automatically adds those pages. I think that would be a good point to add a separate trace module so that people who are okay with the overhead that the trace adds can just add or not add that single module to allow for tracing. Hope that answers the question.
All right, any further questions? All right, let's give one last round of applause.